Hello everyone, good evening. So here we shall solve some more KCET previous year questions on the chapter Basic Principles of Organic Chemistry. So any doubts if you have in any steps of the solutions, then please write that in the comments section. We shall obviously clarify them in the subsequent videos. Also in any other chapter of chemistry, if you have more difficulty, then please mention the name of that chapter also in the comments section so that we can give more priority on it and solve more and more questions that chapter. Mm. Also some important homework questions on every chapter of chemistry will be uploaded in the Sapience Education application. So please install our Sapience Education application whose link has been provided in the description. So here it is told methoxymethane. Methoxymethane means CH3O CH3, which is an ether, and ethanol. Ethanol means CH3CH2OH. So ethanol and methoxymethane. So one is the ether group, one is the ether functional group, and one is the alcohol functional group. So their molecular formula are same only for both methoxymethane and ethanol. They both have the same molecular formula, which is C2H6O, but their structural formula is not the same, and their functional group is not the same. So they are functional isomers. They're functional isomers. So option A is the correct answer. Then here it is told the IUPAC name for tertiary butyl iodide is. So tertiary butyl iodide. So tertiary butyl is like this. So tertiary butyl iodide. So this is CH3, CH3, and CH3. So tertiary butyl iodide. So its name will be. So it is a 3-carbon chain. So it will be two iodo, two iodo, and two methyl propane. Since why we have to number it like this 1, 2, 3. So in the second carbon only we have the methyl group and the iodo group. So option B is the correct answer. Then it is told mesomeric effect involves delocalization of. So it will be pi electrons. Mesomeric effect, it means that suppose if we have uh, suppose if we have two double bonds, so then this one, these pi electrons, it can come here, and these pi electrons can come here, and it can form one more resonance structure which will be like this. So mesomeric effect, and it involves delocalization of pi electrons. So option C is the correct answer. Here it is told which of the following species does not exert a resonance effect. So C6H5OH, so it is called phenol. C6H5OH. So oxygen has got two lone pairs, so it can come here and then it can come here. So here also resonance can happen. And then C6H5Cl, C6H5Cl. This is called phenyl chloride or chlorobenzene. So here also lone pair is there, 3 lone pairs. So it can form. So these lone pairs can come here. So here resonance effect can be there. And in CH and C6H5NH2, sorry, in C6H5NH2, here also on nitrogen we have one lone pair, so it can get delocalized here. So here also resonance can be there. But in case of C6H5NH3, the NH3 plus, so here we have NH3 plus, so it has no lone pair on it. Here no lone pair is there on nitrogen. So here there can be no resonance effect. There can't be any resonance effect. So option D is the correct answer. The chemical name of anisole is anisole. It means that on the benzene ring we have one OCH3 group, OCH3, which is the methoxy group. So it is called methoxybenzene. So this one is called anisole. So its IUPAC name or its chemical name will be methoxybenzene. So option D is the correct answer. IUPAC name of this is how much? So it is uh, 3 methyl groups it has. So it is actually tertiary butyl chloride, but it is the common name. So the common name is tertiary butyl chloride, but it is not the IUPAC name. Your IUPAC name is ARC. So we have to take this 3 carbon chain. So its IUPAC name will be 2-methyl, 2 first, so 2-chloro, 2-methyl, then propane. Option B is the correct answer. In Geldal's method, ammonia from 5 gram of food neutralizes 30 centimeter cube of 0.1 normal acid. The percentage of nitrogen in the food is. So therefore here the percentage of nitrogen in the food, so that will be equal to percentage of nitrogen in the food. So it will be 1.4 into the normality of the acid times the volume of the acid divided by the mass of the ammonia or the weight of the ammonia uh, or the weight of the food which has been used. So this much percent. So it will be 1.4 times the normality of the acid, that is 0.1, into the volume of the acid, which is 30 centimeter cube, divided by, so the volume of the acid, so that will be, okay, so divide by 5 gram, so this much percent. So this will be 5 6 are 30, so 6 into 0.14%. So that will be 6 4 the 24, 6 1 the 6, 0.84%. So option A is the correct answer. Chloroacetic acid is a stronger acid than acetic acid. So this can be explained using, so chloroacetic acid means CH, CH2Cl COOH. Chloroacetic acid is more stronger than acetic acid, CaCOH. Since why chlorine, since why chlorine's the Cl has got minus I effect. Chlorine has got the negative inductive effect. Negative inductive effect. So it means the hydrogen which is present here, this hydrogen will be more acidic than this hydrogen in the acetic acid. So it can be explained by using minus I effect. Option B is the correct answer. So then we have to find the IUPAC name of this compound. So here we have CHO group, we have carbon, here we have carbon, and here we have carbon, here Br. So it is a, so here we should use this aldehyde group since it is a chain terminating group. So it is 1 2 3 4 5. So it is a 5 carbon chain. So it will be 3 bromo, 3 bromo, and 2 methyl. 3 bromo, 2 methyl will be pentanol. Pentanol. Since we have aldehyde group, so 3 bromo, 2 methyl pentanol. So option D is the correct answer. And here again it is asked 1.2 gram of the organic compound, 1.2 gram of the organic compound on gel-dalization liberates ammonia, which is NH3, and that ammonia consumes HCl. How much? It consumes 30 centimeter cube of one normal HCl. Then the percentage of nitrogen in the organic compound is. So now the percentage of nitrogen in the organic compound, when it is so when the Geldel's method is used, when Geldel's method is used, so then the percentage of nitrogen in the organic compound, that is calculated as 1.4 into the normality of the acid times the volume of the acid in centimeter cube, that divided by the mass or the weight of the organic compound which is used in grams. So that will give us the percentage of the nitrogen in that organic compound. So now here the normality of the acid which is used, that is 1 normal, and the volume of the acid in centimeter cube, that is 30 centimeter cube, that divided by weight of the compound in gram, that is 1.2 gram. So then this much percentage of nitrogen is present in that organic compound. So it will be, point will get cancelled, then 2 6 are 12, 2 7s are 14, then 6 5s are 30. So 7 5s are, this is 35%. So 35% of that organic compound is nitrogen. Option B is the correct answer. Okay. Then here it is told that which one of the nitrogen atoms in which one of the nitrogen atoms in NH2, NH, CONH2 is the most nucleophilic. So nucleophilic compound, it means that which can accept lone pair of electrons, means which is a Lewis acid. Nu- nucleophilic. Nucleophilic, it means that which can give lone pair of electrons, which can give lone pair of electrons, or I can say which is a Lewis base, which is acting as a Lewis base. So here, which nitrogen among 1, 2, and 3, which nitrogen is most nucleophilic? It means that which can most easily give the lone pair of electrons. So now, so since here we have the carbonyl group here, the carbonyl CO group is attached. So here resonance can be formed with these two lone pairs of on the nitrogen atoms. Here all the nitrogen atoms has got lone pairs on it, but these two can involve in the resonance. So these two lone pairs can get easily involved in the resonance with the carbonyl group here, but this lone pair can't get involved in the resonance. So it means that this nitrogen can more easily give this lone pair to someone else. So it means that the nitrogen atom 1, so here it means the nitrogen atom 1 is the most nucleophilic. Is the most nucleophilic since it can more easily give the lone pair. It can more easily give its lone pair on it. Since why the lone pair can't get involved in the resonance. Since it can't get involved in the resonance. It can't get involved in the resonance with this carbonyl group. So option B is the correct answer. Then the IUPAC name of this compound we have to find. So it is like this. So here we have COH group, and here we have one carbon, and here double bond, here one more carbon. So it is butene. It is, so I can write 1 2 3. It is but3 enoic acid. But3 enoic acid. Since why on the third carbon only we have the double bond here, and on the first carbon we have the carboxylic acid group. So option A is the correct answer. Then here it is told that an oxygen containing organic compound was found to contain 52% carbon and 13% of hydrogen. Its vapor density is 23. The compound reacts with sodium metal to liberate hydrogen. Functional isomer of this compound is, so now we know that molecular mass molecular mass equals to twice of the vapor density. So therefore here the molecular mass, that will be equal to twice 2 times of 23, that is 46. So now, so it contains oxygen. So the organic compound contains carbon, hydrogen, and oxygen. So here carbon is present 52%, hydrogen is present 13%. Therefore, oxygen should be present. This will be 65, 65. So it will be 35. 35% oxygen is present in that organic compound. So now the atomic masses, the atomic mass of carbon, that is 12, and for hydrogen it is 1, for oxygen it is 16. So now therefore the relative number of atoms of carbon, that will be 52 by 12, means the relative number of the atoms we have to find in that organic compound. If 100 gram of that organic compound is taken, if 100 gram of that compound is taken, so if 100 gram of that compound is taken, it means that 52 gram will be carbon, 13 gram will be hydrogen, and 35 gram will be oxygen. So the relative number of atoms of carbon, that will be equal to 52 by 12. So that will be equal to 4 3 is a 12, 4 and 4, 4 3 is a 12, 3 4 is a 12, 4.33. And then the relative number of atoms of hydrogen, that will be 13 by 1, so that will be equal to 13. And the relative number of atoms of oxygen, so that will be 35 by 16, so that will be approximately 2.18. So we have to take the simplest ratio, so that is 4. So therefore the ratio of the atoms, of carbon, hydrogen, and oxygen, that will be equal to mm, 4 is to, so that is 4.33 is to 13 is to 2.18. So that will be equal to approximately, this will be 2, and this will be approximately 6. This will be 1. approximately. So therefore the empirical formula of that organic compound, that will be equal to C2H6O. So therefore the empirical formula mass, that will be equal to 2 into 12 plus 6 plus 16. So that will be 24 plus 6 is 30, so 46. Therefore, the molecular mass is also 46. Therefore, N will be equal to molecular mass by empirical formula mass, which will be equal to 46 by 46, which is equal to 1. Therefore, the molecular formula, the molecular formula of that compound, that will be also C2H6O. And it reacts with sodium to liberate hydrogen. Now, C2H6O, it liberate hydrogen with the, so C2H6O, we can have like CH3O CH3, or we can have CH3 CH2OH. So it means that mm, so now alcohols, we know that alcohols can liberate hydrogen if they react with sodium. If it reacts with sodium, then it can liberate hydrogen. Yes. So it means that it will be CH2, CH3, CH2OH only. I can say C2H5OH. So it will be ethanol. Be ethanol. So option A is the correct answer. So here it is told that which of the following is not true regarding electromeric effect. So electromeric effect, it means the effect of the complete transfer of a shared pair of electrons to one of the atoms joined by a multiple bond at the requirement of an attacking reagent. So it results in the appearance of partial charges on the carbon atoms. So in electromeric effect, what happens? Uh, the shared pair of electrons on one of the atoms mm, joined by a multiple bond at the requirement. Okay, so these shared pair of electrons will be transferred. So the complete transfer of a shared pair of electrons, complete transfer of a shared pair of electrons on one of the atoms, which is joined by a multiple bond. It means which is joined by either a double bond or a triple bond. Um, in the presence of an attacking reagent. And the presence of an attacking reagent is called as electromeric effect. Mm. called electromeric effect. So here, when the shared pair of electrons will be transferred, so then obviously some charges will be formed on the carbon atoms. Some partial charges will be formed on the carbon atoms, and it is okay. So here, actually, partial charges will not be formed here. Complete charge will be formed on the carbon atoms, and it is obviously a temporary effect. It is a temporary effect, and it operates on multiple bonds also, and it requires an attacking reagent. So in the presence of some attacking reagent only, this electromagnetic effect will take place. So it means option A is the wrong statement, so it is the correct answer. Then here it is told the CH bond and CC bond in ethane are formed by which of the following types of overlap. So in ethane, as you know, it is C2H6. This is ethane. So here all the CH bonds are sigma bonds, and all these CH sigma bonds are sp3s sigma bond, and the carbon carbon bond is sp3 sigma bond. And the carbon carbon sigma bond is sp3 sigma bond. Option A is the correct answer. The IUPAC name of this compound is what that you have to find. So we know that the alcohol group will act as a substituent since the ketone group is more senior than the alcohol group. So it will so its name will be, this is OH. So the numbering should start from here. So the numbering should start from here. So it will be 1, 2, 3, 4, and 5. So it is 4 hydroxy. Since here alcohol group is less senior than ketones, so it is acting as a substituent. So it should be its name should be written in the prefix. So 4 hydroxy uh, pentan pentan 2 on, or we can write 2 pentanone also. So 4 hydroxy 2 pentanone. So option A is the correct answer. And acetone and propanol are acetone means the CH3CO CH3, which is the acetone, or it is called propanone, and propanol is CH3 CH2 CHO. This is propanol. So these two are obviously they are functional isomers. Since why this one is ketone group and this is aldehyde group, so their functional group is not same, but their molecular formula is same. So ketone and aldehyde, they are functional isomers. So option A is the correct answer. IUPAC name of this compound is what? Okay. So here, this is CH3, CH, CH2, CH, then CH3, then COOH, and this is OH. So I should, so here carboxylic acid group is more senior than hydroxy group, than alcohol group. So we have to take the longest carbon chain, including the senior functional group. So this will be 1, 2, 3, 4, 5. So its name will be 4 hydroxy, 4 hydroxy 2 methyl, 4 hydroxy 2 methyl, then pentanoic acid. So option A is the correct answer. No, option B is the correct answer. 4 hydroxy 2 methyl pentanoic acid. Option B is the correct answer. Then here it is told carbocation as an intermediate is likely to be formed in which of the reaction. So when sunlight with propene in the option A, when propene means CH3, CH, CH2. So propene is acting with Cl2 in the presence of sunlight, then here 2-chloropropane. 2-chloropropane is formed. So here when sunlight is used, then free radicals are formed. Here carbocation is not formed. So in B, acetone, which is CH3COCH3, if that reacts with HCN, then here carbocation, here also HCN, and then OH, in the presence of OH, then acetone cyanohydrine that is formed, means CH3, CH3, then CN, then OH, acetone cyanohydrine that is formed. Here also carbocation is not formed. In bromide, ethyl bromide, that is CH3, CH2Br, in presence of aqueous KOH, and if we heat it, then ethyl alcohol is formed. CH3, CH2OH is formed. So here also carbocation is not formed. But in option D, here hexane, which is CH3, CH2, 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 CH3, hexane, that is reacting with anhydrous AlCl3 with HCl. So then 2-methyl pentane will be formed. So here carbocation will be formed. Here 2-methyl pentane will be like this. Means there is a methyl shift. Okay. So in the option D only, carbocation will be formed. Option D is the correct answer. Then which of the following compounds possesses the CH bond with the lowest bond dissociation energy? Which of the following compounds possesses the CH bond, the lowest bond dissociation energy? So here in benzene we have uh, 6 CH bonds and 2 dimethyl propane, 2 dimethyl propane, which is also called neopentane. Then in toluene, toluene is like this, which is methyl benzene. Uh, then n-pentane is like this, CH2, 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 CH3. Okay. So which of the following has the lowest bond dissociation energy? So when when one CH bond is removed, so then CH2 plus ion will be formed and hydride will be removed. So here the carbocation which is formed, it can form re- resonance with this benzene ring. There will be a resonance effect with this benzene ring. Since why these these pi electrons can go here, and again this can go here. So it means the this positive charge, it can shift here also, or it can shift here also, or it can shift here also, here also. So it means there is a delocalization of this positive charge throughout the benzene ring. So this positive charge will be more stabilized in the case of toluene if one hydride H minus is removed. So it will have the least bond dissociation energy. So toluene only will have least bond dissociation energy. So option C is the correct answer. And IUPAC name of this compound is, so here is actually CH3, then CH, double bond CH, then we have CH2 Br. So it will be, that is 1 bromo, 1 bromo but 2 in, 1 bromo but 2 in. So option A is the correct answer. When it is told miscible mixture of C6H6, which is benzene, and CHCl3 can be separated by. So this mixture can be separated by using the distillation process only, since they will have different boiling points. Since they both are liquids only, CHCl3 is the chloroform, and this is benzene. So they are in the liquid states only, and since they have different boiling points, so they can be separated by using the distillation process or fractional distillation process. So option B is the correct answer. Then it is told identify the correct statement in the following. Dimethyl ether and ethanol are chain isomers So dimethyl ether, CH3OCH3, dimethyl ether and ethanol, CH3CH2OH. So these two are chain isomers. So they are not chain isomers, they are functional isomers. Then ethanoic acid means CH3COH and methyl methanoate, which is CH3COOCH3. Methyl methanoate, ethanoic acid are position isomers. No, they are not even isomers since their molecular formula is not the same. Then N-butane, N-butane and isobutane, they are functional isomers. So they are not functional isomers, uh, they are chain isomers since the length of the main chain is not the same. They are chain isomers. And propan 1-ol, propan 1-ol and propan 2-ol. So they are position isomers. They are position isomers uh, since here in both these compounds the position of OH is not the same. OH group is not the same. So option D is the correct answer. Then in which of the following mm, homolytic bond fission takes place? In which of the following homolytic bond fission takes place? Free radical chlorination of methane, alkaline hydrolysis of ethyl chloride, addition of HBr to double bond, nitration of benzene. So homolytic bond fission, if it take place, it means that free radicals should be formed. Free radicals should be formed and free radical chlorination of methane. Yes, so which will happen in the presence of sunlight. So option A is the correct answer. And then alkaline hydrolysis of chloride. Ethyl chloride, alkaline hydrolysis. So here free free radical is not formed. And then addition of HBr to double bond. Here also carbocation is formed. So here homolytic bond fission does not take place. Then nitration of benzene. In nitration of benzene also uh, homolytic fission does not take place since free radicals are not formed. So free radicals are formed only in case of chlorination or halogenation. Chlorination of methane or any other compound or any other hydrocarbon in the presence of sunlight. Then during the fusion of an organic compound with sodium metal, nitrogen of the compound is converted into. So when an organic compound is fused with the sodium metal, so then the organic compound contains carbon and nitrogen. So this nitrogen is converted into NaCl Cn, which is also called the Lasig Lassignes test. Lassignes test, which is used for the de- uh, detection of nitrogen, sulfur, or halogens in organic compounds. So the Lassignes test, it is used to detect the presence of nitrogen, sulfur, and halogens in the organic compounds. So option D is the no, option C is the correct answer. Then here it is told that the number of pi bonds and sigma bonds present in naphthalene are respectively. So in naphthalene, the structure is like this, where we have two benzene rings which are connected side by side. Two benzene rings which are connected side by side. So here we have number of pi bonds is 1, 2, 3, 4, 5. So there are 5 pi bonds, and sigma bonds, number of sigma bonds that are present. So here hydrogen, carbon, hydrogen bonds are also should be counted. So it means here we have 1, 2, 3, 4, 6, 7, 8, 8 plus 1, 2, 3, 4, 5, 6, 6 plus 2, 3, 4, 5. So 6 plus 5. These many sigma bonds, which is 11 plus 8, that is 19 sigma bonds. So 19 sigma bonds and 5 pi bonds. So option B is the correct answer. Then resonance effect is not observed in. So here the option A, CH2 double bond CH, CH double bond CH. So here resonance effect can be observed since these pi electrons can go here and this pi electrons can come here. So then it can form CH2 minus, means one carbon ion, and CH double bond CH, and then CH2 plus. So here resonance effect can be observed, and in the option B, CH2 double bond CH, C triple bond N, here also resonance effect can be observed since these pi electrons can come here and these pi electrons can go to nitrogen. Then it can form CH2 plus and then CH double bond C double bond N minus. So here also resonance effect can be observed in the option C, CH2 double bond CH single bond Cl. So Cl has got three lone pairs. So so these electrons can go here, this one can go here. So then it can form CH2 minus, then CH, then Cl plus. So now, and in the option D, so in option C also resonance effect can happen, but here the option D we can see that CH2 double bond CH single bond CH single bond NH2. So nitrogen has got one lone pair here, but it cannot undergo resonance since if it comes here, then there is no multiple bond here which can get transferred. So here there is no resonance effect. There is no resonance. So option D is the correct answer. Which of the following is not a pair of functional isomers? Which of the following is not a pair of functional isomers? So first one is ethyl alcohol, means ethanol, and acetone, ethanol and acetone. So they are functional isomers. And in CH3, CH2NO2 and CH2NH2COOH means it is CH3, CH2, NO2, NO2, and we have CH2, NH2, and then COOH. So here also they are not functional isomers. And then CH3COH and HCOCH3. So these are also functional isomers. They are also functional group isomers since the functional groups has changed. In the first one, they are also functional isomers. And in CH3COH, CH3COH, and CHCOOCH3, so they are also functional group isomers. Since why one here also one is ester and one is carboxylic acid group, and here also it is acid and amine, so it is an amino acid, and this one is a nitro group, so the functional group is not same. And here also it is alcohol and this one is ether, so here also the functional groups are not same. So they in the first three options they are functional isomers, so it means the option D should be the answer. And it is not a functional isomer also, since it is C2H5 means CH3 CH2O CH2 CH3. It is ethoxyethane, and this one is C3H7 means CH3 CH2 CH2, then O, then CH3. So it is methoxypropane. So they are not functional isomers. They are called as metamers. They are called metamers since the two alkyl groups which are attached on the two sides of the polyvalent functional group are not same. So option D is the correct answer here. So here it is told the IUPAC name of this compound is, so it is C double bond C, then CH3, CH3, then CH3, CH3. So here we have to take the longest chain, so which is this one, 1 2 3 4. So I can say it is 2 3 dimethyl, 2 3 dimethyl, then then it is 4 carbon atoms chain, so it is but and one double bond, so but 2 in, so 2 3 dimethyl but 2 in. So option C is the correct answer. So hope all of you have understood the solutions of all these questions based on the previous year KCET exam on the chapter Basic Principles of Organic Chemistry. Still any doubts if you have, please write that in the comments section. We shall obviously clarify them. Um, Also, please install our Sapience Education application where we shall upload some important questions on every chapter of chemistry which are based on the previous year KCET exam. So thank you everyone. Bye.